All right, stats. Now we're going to look at significance tests for a difference between two means. So if we need to build our hypotheses and we need to check our conditions, here's what we do. All right. So for the hypotheses, again, we're going to assume that there's no difference between the two means. Right. So if there's no difference, that means mu1 minus mu2 equals 0, or better or easier to write, mu1 equals mu2. They're identical. For the alternative hypothesis, that's the null. For the alternative hypothesis, again, one-sided greater than or less than, two-sided not equal to. Again, your conditions are the the random and the normal large sample. Remember, the normal large sample has one of three things that must, just one of them out of the three must be satisfied. Okay, so when we're finding the standardized test statistic, we're finding the t-value. Again, it's sample mean 1 minus the sample mean 2, minus 0, which is the null value, but again, we don't really write that. So that just the difference in the means divided by the standard deviation, right? And that's, or the standard error, I should say, using these sample standard deviations and the sample sizes. To find the p-value, again, you use table B. Remember, you have to choose the smaller degrees of freedom if they're not identical. And again, we're looking for an interval. Remember, the way that we use table B is we find the two values that our t value falls in between, and we go up to the p values at the top of the chart. And again, this significance test is called a two-sample t-test for mu1 minus mu2 for a difference in means. Okay. Ready to go, I think. Here we go. Okay. Example 2, does caffeine increase pulse rates? Mr. Lucklow's class performed an experiment to investigate whether drinking a caffeinated beverage would increase pulse rates. 20 students in the class volunteered to take part in the experiment. All the students measured their initial pulse rates. Then Mr. Lucklow randomly assigned the students into two groups of 10. Each student in the first group drank 12 ounces of cola with caffeine. Each student in the second group drank 12 ounces of caffeine-free cola. All students then measured their pulse rates again. The table displays the change in pulse rate for the students in both groups, along with parallel dot plots and summary statistics. Okay, so there's your data. Down here are your parallel dot plots. Let me take this away. Let's see if we can unhide that. I just don't move, right? So there's your caffeine group and your no caffeine group at the bottom. There we go. And then here's your summary statistics. So the question is, do these data give convincing evidence at the alpha equals 0.01 significance level that drinking caffeine increases pulse rates on average? Let mu1 minus mu2 be the difference, caffeine versus no caffeine. So again, these numbers represent the change in pulse rate. There's the mean change. So now we're trying to figure out if there is a significant difference here. All right. So if I come here, this slide gives us our state and our plan. So state, we want to perform a test at the alpha equals 0.01 significance level of the null hypothesis, mu1 equals mu2, versus the alternative hypothesis where mu1 is greater than mu2. That means the caffeine causes a higher pulse rate or higher change in pulse rate than the non-caffeine. Where mu1 is the true mean change in pulse rate for all students in the class who drank cola with caffeine, and mu2 equals the true mean change in pulse rates for all students in the class who drank caffeine-free cola. Your plan is a two-sample t-test for mu1 minus mu2. And now you pick it up from here. Let's finish the plan. So when you do the plan, you got to do the two conditions, right? So let's first do the random condition. So 20 students volunteered. Then Mr. Lucklow randomly assigned the students into two groups of 10. So that's where we're going to put randomly assigned the students into two groups of 10. Good. And now we do the normal large sample. So I don't see the word normal in the problem. The sample size are 10. That's not greater than or equal to 30. So I need to go back to, let's see how easy this is. Got to go back there. Okay. And if we look at the dot plots, I know my writing's in the middle, but again, we're looking for strong skewness or outliers. In the top group, that 8 is not a strong enough outlier, and there's no real skewness, right? I know that there's a bunch of 2s on the left, but don't worry about it. Again, if I were to use, if I were to use a pen and try to sketch this, again, it would look like this, which I could see being a little skewed to the right, but we're not going to say it is. And then down here, definitely, right, you go down, up. Okay, again, the data is so few that it has, like, they all have to be stacked over here and one's over there, whatever. So this does not show strong skewness or outliers, either of them. So we're good to go. Okay. So let me go forward. This night that it stayed. All right, we're going to say that the dot plots of the sample data show no strong skewness or outliers. And there we go. And now that the two conditions are met, we are free to go through with the problem. And that's what we'll do. All right, so here's what we're going to do. We're going to find our test statistic, okay? So to find T, we need mu1 minus mu2. So mu1 is your caffeine. So ones, right, and twos. So this is we need X bar one. I'm sorry. These are your X bars. This is your SXs, right? So we're going to do 3.2 minus 2 over a big square root 2.7 squared divided by 10 plus 2.625 squared divided by 10, right? And this will get us our T star value, and we're going to round that to 3 decimals. So let's go do that now. All right, so let's go back here. Let's delete some of this. Okay, so I'm doing fraction 3.2 minus 2 over the square root fraction 2.7 squared over 10 plus fraction 2.625 squared. And there we go. 1.007. The 7 rounds to 7 to an 8. So your T value is 1.008. So now we need to look at our degrees of freedom. So both sample sizes, df1 is going to equal df2 because both sample sizes are 10 and 10 minus 1 is 9. So there's our degree of freedom row. We're looking for the T star value. T star values that encompass 1.008. So let's go there now. So I'm looking for row of 9. Looking for 1.007. So 9. So 1.007 would go right in here between 0.883 and 1.110. So that's going to involve these two probability values, 0.20 and 0.15. So I'm going to take a picture of some of this stuff. So again, what I like to do is I like to write a whole bunch of stuff down, just because the more information you give me, the better off I know what you're doing. Okay. So if I go back to my problem here, whoops. Okay. So still within the do. So from table B, I got these two values. So the two T values are 0.883 and 1.100. And if you look up, the P values associated are 0.15 and 0.20. So notice the order that I do them in, right? 0.15 to 0.20. And again, I might have to multiply these by 2 if the test is a two-sided test. But the alternative hypothesis is saying that mu1 is greater than mu2. That's one-sided, so leave it alone. So there's your p-value, 0.10 to 0.20, or 0.15 to 0.20. Okay, and now we need to conclude. So we're going to conclude like this. So when we do our conclusion, we always compare the p-value to, the p-value to the significance level. So our p-value of 0.15 to 0.20 is greater than 0.01. So we fail to reject the null. Therefore, there is not convincing evidence And now again, I like to interpret the alternative, which was this, mu1 greater than mu2. There is not convincing evidence that the true mean change in pulse rate for all students in the class who drank cola, 1L, cola with caffeine is greater than the mean change in pulse rate for all students in the class who drank caffeine free. Okay, so basically, based off this, we're saying that the caffeine didn't raise their pulse rates enough to show a significant difference. So again, p-value of 0.15 to 0.20 is greater than 0.01, so we fail to reject null. There's not convincing evidence that the true mean change in pulse rate for all students in the class who drank cola with caffeine is greater than the true mean, than the true mean change in pulse rate for all students in the class who drank caffeine-free cola. And there we go. Okay, and there is our significance test for a difference in means. Again, one problem in your homework. Best of luck. Ask questions if you have them.